right, 7.2, antidifferentiation by substitution. The family of all antiderivatives of a function f of x is the indefinite integral of f with respect to WRT is with respect to x and is denoted by the integral from the integral of f of x dx. So notice there's no parameters on it anymore. If capital F is any function such that capital F prime of x is equal to little f of x, then the integral of little f of x dx is equal to big F of x plus c, where c is an arbitrary constant called the constant of integration. Properties of indefinite integrals. It's pretty much going to be the same stuff we saw for the definite ones, but they do it again. So the integral from, not from, my goodness, I have to stop saying from because we're not on those anymore. The integral of k times f of x dx is equal to k times the integral of f of x dx for any constant k. So that's one where we can just take out any constant because it's not going to change the end result. Then I have the integral of f of x plus or minus g of x dx is equal to the integral of f of x dx plus or minus the integral of g of x dx. So that's just the same thing where we can split them up into two pieces if there's things being added together. Next, we've got the power formulas. The integral of u to the n du is equal to u to the n plus 1 over n plus 1 plus c for n not equal to -1, because that is going to give us a different situation. The integral of u to the -1 du is equal to the integral of 1 over u du, which would be equal to the ln of the absolute value of u, because we can't have a negative in our log, plus c. trig formulas. Should be a review for you, but the integral of the cosine of u du is equal to the sine of u plus c. The integral of the sine of u du is equal to minus cosine of u plus c. The integral of secant squared of u du is equal to tangent of u plus c. The integral of cosecant squared of u du is equal to minus cotangent of u plus c. Then the integral of secant of u, tangent of u, du is equal to secant of u plus c. And the integral of cosecant of u, cotangent of u, du is equal to minus the cosecant of u plus c. Can I go to there? Okay. Then the next one's exponential and logarithmic formulas. The integral of e to the u du is equal to e to the u plus c. The integral of a to the u du is equal to a to the u over the ln of a plus c. Then the integral of the ln of u du is equal to u ln of u minus u plus c. And then the last one, integral signs are getting worse progressively. The integral of log base a of u du is equal to the integral the ln of u over the ln of a du is equal to u to the ln of u minus u over the ln of a plus c. So all of these, you're going to want to make sure you've memorized. Now, the trig ones, we've pretty much already used before. The log and exponential ones, we've more or less used before, but that bottom one changes this from the change of base formula to make it easier, and then goes on to integrate that. In this section, okay, obviously with the title of Antidifferentiation by Substitution, you can assume that we're going to be doing a lot of substituting to be able to integrate things that we wouldn't otherwise recognize how to do. In the last section, we had a few things that periodically we had to really sit down and think about, but in this one, you wouldn't, in most cases, just see what you need to do. And so we'll be using u and then taking the derivative of u to rewrite things in terms of u's, which is why all these formulas are written that way. so that it'll make your life a little easier when we go to do examples. So.